Good Thursday afternoon, everyone. Welcome to lecture 14, Mathematics for Construction. So we want to look at the textbook. Wow, not this topic. This topic here in the textbook, something called number sequences, right? So in your syllabus, there's a course outline here, right? We have a lot of stuff happening all over the place. We kind of finished calculus. That's the big bad topic in this course. That's your P5, your P6, your M3, and your D2. This LO3 is calculus, right? There are some small topics that I want to start talking about that really don't take a lot of time, right? This LO4. We're gonna start talking about some of these things here in LO4, and then we'll jump back to LO1 and do trigonometry, and finally we'll do the statistics, right? Now I'm kind of doing an overview of these topics here, right? So let me check the textbook. A number sequences, and this is this part here, generalized answers from arithmetic progression problems, right? So we want to do something called a arithmetic progression, or what we call APs, right? If you ever anybody in mathematics say they like APs or remember doing APs, AP is short for arithmetic progression, okay? So again, and it makes no sense to give you a bunch of notes when we have a textbook, okay? Class is not really for notes. Class is really for solving problems and showing you techniques and tricks to solve difficult problems, right? This is not a topic you should try to do if your algebra skills is weak, right? Number sequences. So first of all, what's a sequence? What was a sequence? You really need to know that rigorous definition. Is a very rigorous definition of a sequence, right? Is a function. But just think about a list of numbers that somebody write down in some particular pattern. Like if I give you the sequence 1, 2, 3, 4, 5, okay? You could probably figure out what the next term is. The next term is 6, right? Or if I give you, 2, 4, 6, 8, right? You'll say, well, the next term is 10. Those are simple sequences. A sequence is just a list of numbers separated by commas. This is a sequence here, 1, 4, 7, 10, 13, right? Now I have all kinds of different sequences in mathematics. The easiest sequence in the whole of mathematics to deal with is a sequence called arithmetic progression. Arithmetic progression is a special kind of sequence that there's a certain property that the elements of the sequence obey, right? They say here when a sequence has a constant common difference between successive terms, it is that sequence is called arithmetic progression. What is this common difference here? So look at the numbers 1, 4, 7, 10, and 13. What they're saying is to go from one number to the next number, you have to add a constant number. So to go from 1 to 4, well, add 3. And then to go from 4 to 7, add 3. Then 7 to 10, add 3. 10 to 13, add 3. See? The difference between successive terms, this highlighted thing here, that difference between successive terms is constant. It doesn't change. Notice they say successive. They don't say take 4 minus 4 from 13 and that's the difference. They mean terms next to each other. So to go from 7 to 10 is the same as going from 7 to 13. The difference is common. That's why they call it the common difference, right? So the common difference is 3. Algebraically, arithmetic progression is represented like this. The first term is A, right? The second term is A plus D. D is the common difference. The third term is A plus 2D, and so on and so forth. So we could generalize that now. If the first term of arithmetic progression is A, and the common difference is D, then the nth term is A plus n minus 1D. How do I get that? Well, look here. First term is A, second term is A plus 1D, the third term is A plus 2D. You see any pattern there? The fourth term is A plus 3D. So the nth term is just a plus 1 less than n by d. Okay? So that's what they're kind of trying to hint at here. Again, you don't understand the rigorous proof of these things. You just need to understand the concept, right? And then the algebra is supposed to kick in at some point in time and save your life, right? So a sequence is a list of numbers. We're dealing with a special kind of sequence called arithmetic progression. What makes that sequence special is that between successive terms, there's a difference, and that difference is common. If I give you a list of numbers and the difference changing, that can be arithmetic progression. Okay, so we could come here and say, well, you know, arithmetic progression. And I could call it arithmetic series. You could call it, you know, it have synonyms to this thing, right? But APs is the popular name in the literature, right? So any sequence of the form, and write some math here, a comma a plus d comma a plus 2d comma dot dot dot. Right. Okay, so the difference between successive terms is called the common difference. Now, we have some terminology here that you see in the formulas. We'll go back to it just now, right? The nth term, right? So you could write that here, the so, you know, we abbreviating it to AP, what we call arithmetic progression, right? And we get that formula there, A subscript n equals A plus n minus 1 by t. So for an AP with first term, and this is a common convention. The first term is A, right? So I have this formula here. If you know the first term A and you know the common difference D, the nth term is given by this here. So obviously, you know, the first term, we start counting from 1, right? So the first term is what? A1, right? Which is equal to A plus, what we say? N is 1, so 1 minus 1 D, right? Equals A plus 0D, which is A. Okay. Probably write that. Convert this to block. So since we start counting from 1, the first term is given by n equal 1. Right? An equation above. So A1 is A. We abbreviate it to A, common A, right? That's kind of what it's saying here, right? A is the first term, and the common difference is D. That's just the letters we tend to use to represent it. The letters D, right? So the first formula for arithmetic progression that is important is the nth term, right? So reading on here, they say the sum S of an AP can be obtained by multiplying the average of all the terms by the number of terms, right? So this is a way of proving it, okay? Proving it, you know, how they arrive at the sum of all the terms of an AP, right? So, you know, like you want to find the sum of all the terms in an arithmetic progression. But I remember arithmetic progressions are infinite things. They don't ever end. Think about it, 2, 4, 6, 8. When does that end? Nobody knows when that ends, right? That's an infinite sequence. It doesn't stop, okay? So you don't say the sum of all the terms in an AP. They usually tell you which terms they want to add up, right? So one of the more useful techniques is the sum of the first n terms of arithmetic progression of an AP, right? So like if I have an AP, say, let me give an example here. Example 1, right? Find the 7th oops. Okay, so I give you this problem here. This arithmetic progression here. What I told you is a AP, right? They say find the 7th term and the sum of the first 10 terms. So you know how you do something like this. I'll show you the hard way and the easy way, right? So since this is a AP, right? I could just list out all the terms, right? How you sure this is arithmetic progression? All you need is 3 terms, all you need is 3 terms in a sequence to figure out if it's an arithmetic progression. 3 consecutive terms, right? So I have 3 consecutive terms here, 8, 10, and 12. I need to check and see if the common difference from the first to the second is the same as the difference from 10 to 12. To go from 8 to 10, I need to add 2. And to go from 10 to 12, I need to add 2. Since I'm adding the same thing to go between consecutive numbers, that means the common difference exists and it's a constant. So then it's arithmetic progression. That's the only thing you could do to verify something's arithmetic progression. The difference between successive terms is constant, you see? Constant difference between successive terms. And all you need is 3 terms. The difference between the first 2 is the same as the difference between the second. Now be carefully order you add them. Is usually the one after minus the one before, right? So 10 minus 8 is the same as 12 minus 10. The order is important, right? So I could just list out all the elements of this thing here, right? So 8, 10, 12, it'll be 14, 16, 18, 20, 22, 24, 28. That's the period. This is the hard way of doing this problem, right? The one day 7th term. Now this is the first term. 8 is the first term. So I could manually write it out 1, 2, 3, 4, 5, 6, 7. So the 7th term is 20, 8, 9, 10. So these are the 10 terms here. Add up all these numbers here. All right, and that's the sum. So that's the hard way of doing it, right? But if I change this 10 here to 107, then you ain't going to list that out, right? Nobody going to answer and write that out. And then that's some kind of terrible, right? Because nobody going to sit down and add up 107 numbers. You might make a mistake. There are better ways of doing this thing, right? So this is not a good strategy, listing out things. That's why these formulas, they come into play and they're very important, okay? So this is a hard way. List out the numbers. If I could spell this. Find the 7th term and manually add up the first 10 terms, right? That's not a good idea. Easier way. Use the formulas, right? So somebody who more awake than I am saw my mistake here is after 24 is 26, right? Not 28. So, okay. So, you know, what are the formulas, right? We could just recall. We could recall the formulas. Yeah. So this is an. A is equal to 8, right? D is equal to 2, right? So we know the formulas here, and we know what the values D and A are. They give it here. This is an easy question. The first term is A, which is 8, and the common difference we saw from the 3 terms up here. To go from 8 to 10, I add 2. To go from 10 to 12, I add 2. So the common difference is positive 2, right? So A is A1. So that means A7 is equal to A plus 7 minus 1 by 2. Yeah. 2. And of course, A is 8, right? So you just substitute. Put where is A or A1, we say 8, and D is 2, and N is 7. I want the 7th term. That's what I asked for. So you put that here. What is this equal to? 8 plus 6. 6 times 2. 8 plus 12 equals 20. Hey, look, I got 20, right? That listen how it is manually. That was the 7. 1, 2, 3, 4, 5, 6, 7. Ah, yeah. So you see, I didn't need to do all of that, right? So this is the 7th term. Now I want the sum of the first 10 terms. That's what this formula is here. This formula here is the sum of the first n terms of arithmetic progression, right? And you don't really need to understand the proof of it. You just need to know how to apply it. You need to know the actual formula. So let me, backtrack and seal this here. And oops. So the sum of the first n terms of our AP. So yeah, again, AP with A, common difference D. We have Sn, right? Sn equals, there's some fraction here, n over 2. That's what I have, right? N over 2. And brackets 2a, right? 2a plus and minus 1d, 2a plus and minus 1d. So this is the sum of the first n terms. Be careful with that. Not any n terms, the first n terms. So a1, a2, a3 up until an, right? That's our formula there. I could kill this here. So I just need to apply that formula now. So what do they want? Again, straightforward application of this formula. They want S10. So let's substitute into the equation, right? S10, N is 10. So inside of here now, I'm gonna just substitute for that. So where I see n, I'm gonna put 10. So instead of n, I put 10 here. Where's a again? A is 8, right? A is 8, and n is 10, and d is 2. Right? Wow, I have everything I need, right? So let me see. This is 10 over 2 is 5. 5 into what? 2 8s are 16 plus. This is what? 10 minus 1 is 9. 9 2s are 18. Is that looking right? 5. What's 16 plus 18? 34. This is what? 170? I'll just verify that for now. So yeah, if you add up these numbers here, 8 to 26. Let me do that the hard way, right? 8 plus 26. All right. 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 plus 24 plus 26. All right. 70, 170. All right, I get bored doing that, but I make a mistake, right? So yeah, stick to formulas, people, right? So believe it or not, everyone, right? That's the only 2 formulas in this topic that you need to know. The nth term and the sum of the first n terms. So we could go through some problems here that they're work problems, right? Look like we have a sequence here 2, 7, 12, 17. And they say find the nth term and find the 16th term. So watching the sequence here, right? You don't really need more than 3 terms, 3 consecutive terms, okay? Watching the sequence alone, to go from 2 to 7, you have to add a number, right? We're assuming you're adding something because it's APs we're dealing with here. To go from 2 to 7, you have to add what? What's 7 minus 2? 7 minus 2 is 5. Now look at the next 2 consecutive terms. Is the higher term minus the lower term, is that equal to 5 as well? Yeah, the difference is common, is a common difference, right? 7 minus 2 is the same as 12 minus 7, which is the same as 17 minus 12, is 5. So, you know, first term is 2, and the common difference is 5. So if they want the 9th term, you just plug in 9 into this formula here. That's 2 plus 9 minus 1 by 5. It's kind of like what I just did. Same thing with the 16th term, right? So look at this problem now. They said the 6th term is 17 and the 13th term is 38, sorry. Find the 19th term. When you plug n equals 6 and a6 equals 17, you get a plus 5d is 17. And then this other equation, this information here, this means a13 is 38. So a plus 12 is 38. You all recognize what this look like? What does it look like here? For this arithmetic progression, they never told you what the first term was, and they never told you what the common difference is. So you actually don't know that. So you have to find out A and D. Now, this is a pair of simultaneous equations. So again, this is what I tell you, you can't do this topic without your algebra skills being on point, right? If you don't know how to solve simultaneous equations, you're kind of gonna hit a brick wall here. So what they did, they just use the elimination method, they subtract the equations, subtract equation 1 from equation 2. That will eliminate the A. And they just went through the motions here, and knowing A, they found D. And then they substituted to find the 19th term. That's what this is here. So most of the time you're given information, you don't know what A or D is, the first term and the common difference, right? And all these questions here revolve around that notion where the information they give you, they may not always tell you how things are. Like when I give you the sequence like this here, I mean, this is a real easy question. You know, just by watching the numbers, you could verify what the common ratio is, and then you know what D is. And then you know the first term, A. So everything is just substitution. This is a simple question. This is one like I just did here, right? This is something like what I just did, example 1, right? I give you 3 terms. Yeah, you don't want to list these things out, right? You want to use the formula. So you see they use the straightforward formula here. You find that value, right? And if you notice, there's just more worked problems on this topic, you know, further work problems on arithmetic progressions, right? They don't really have anything new to show you anymore. It's just work problems. You just need to sit down and do the problems, right? So they say the sum of 7 terms of an AP is 35. The common difference is 1.2. Determine the first term. So what do we know? We know the first 7 terms, N is 7. We know D is 1.2. And they say S7 is 35. So the total of the first 7 terms is 35. So that means this formula here is equal to 35. So you know you substitute the 1.2, the 7, the 35. The only thing you don't know is A. So again, changing the subject of the formula. This is a core skill in mathematics, right? So if you can't change the subject of the formula, you wouldn't be able to do this question here. So once you know the first term and the common difference, you pretty much know everything about an arithmetic progression. Arithmetic progression is defined by the first term and the common difference, right? It's an interesting problem here. 3 numbers are in arithmetic progression. So 3 numbers, you know, A plus D, and A plus 2D. You could think of it like that. But look, they say let the 3 numbers be A minus D, A, and A plus D. Right? To go from A minus D to A, you have to add D. And to go from A to A plus D, you have to add D. So this is really arithmetic progression here, first 3 terms. First term A, common difference D, right? So they say the sum is 15. So you write an equation here equal 15. And they say the product is 80. So the product of all the numbers here, which is A by A minus A plus D, is 80. I hope you all see in this, it's immediately obvious to you that your algebra skills had to be real good to deal with these kind of things. Because you're going to get quadratics. Once you get quadratics, you're going to have minimum value, maximum value, axis of symmetry, sketching the value, trying to figure out a quadratic inequality, like when is the value more than a certain amount, right? So all your theory relations and functions and quadratics and straight line graphs and simultaneous equations, simultaneous quadratic equation, and so on, all are going to come back in this topic here. This nice simple topic with only 2 formulas. This formula here and this formula here, right? All your algebra are going to come back to haunt you. See, you have surds and things going on here. I teach you all how to deal with that, how to solve a quadratic equation, right? So yeah, that's really the end of the topic, you know. We have nothing really interesting here. The other topic is geometric progressions, which not on this course syllabus. This course syllabus says only arithmetic progressions here. And that is pretty much it. That's pretty much it. I just give you some problems to practice, but yeah, I should suggest you do these problems and check the answers at the back of the book. So here's a question. I want you to try and figure it out. Don't manually sit down and write out all these numbers and calculate it, right? But find the sum of all the integers between 37 and 73 inclusive. So 37, 38, 39, up until 73, right? See what you could use from here to help you out with that. This is just a warm-up problem, right? So, okay. Let's tackle this problem here. All right. Solution 2. So the integers between 37 and 73 form an AP with first term 37 and common difference 1. So I convince yourself about this, right? It goes 37. Remember what integer is, right? Integers are the counter numbers, and they say between 37 and 73 inclusive. So that's 37, 38, 39, you know, going up the road, right? I would not want to sit down and add up all those things by hand. It would take too long. So I know A, remember A, first term, and D. I know A and D. But what we want is between 37 and 73. So all these formulas here have something called the nth term, right? So we need to kind of figure out what n is, right? 73 is what value of n? So let's figure that out, right? So And this is one way of doing it. I have many ways to do this, right? But we're using only the two formulas we have here. So again, if this is the formula AN, A is 37, D is 1. Then AN is equal to 73. That's what we don't know. AN is 73, and that is 37 plus n minus 1. Sorry, n minus 1 by d. Okay. So n minus 1 by d. Remember, d is the common difference, which is 1, because it's consecutive integers, right? All the integers, right? All the integers is consecutive, 37, 38, 39, and so on. So I could use this equation to solve for n. I want to know what is the value of n such that the n term is 73. 73 is which term? Is 73 the 5th term, the 10th term, the 25th term? I don't know. I need to find out. Once I could find out that n, I'll just plug it into this sum formula here. I hope that's what you all did, right? So we go in. 73 is equal to 37 plus n minus 1. This looks fairly simple to solve. N is equal to 73 minus 37. I put in everything over on the other side, plus 1. 73 and 37 is what? Well, I mean, 73 take away 37, right? This is 73 minus 36. I think that should be 37, right? Because 73 minus 36 is if you subtract 3 from these two numbers here, that's 70 minus 33, right? And 70 minus 30 is 40, and then 40 minus 3 is 37. That's how I did it in my head, right? So with this in mind, therefore, 73 is the 37th term in this AP. So then I just need to find the sum of the first 37 terms. Okay. I copy this here. So that wasn't so bad. So it turns out we had to find S37, right? So that is 37 over 2, 2 into 37. Plenty 37s here, boy, wow. By D, which is 1. So my first 37 terms. This is 37 minus 1. This is 36. So I could just take out this one here and just put 36. Let's try and simplify this with some algebra here, right? Isn't 36 2 by 18? Right? So by 18 is 36. So therefore, this 2 in brackets inside here cancels with this 2 here. So this is 37. What is this? What is 37 plus 18? 18 is 15 plus 3, right? 37 plus 3 is 40. 40 and 15 is 55. Divided by 55. The answer is, I mean, I could use a calculator for 37 by 55. That number ends with 5. That's, at least I know that, right? Should be 2035. Let me see, 37 by 55 equal 2035. All right. So that's the sum of all the positive numbers from 37 to 73 inclusive. Okay. And nobody got this answer. Oh, for shame. Hope you all understand how I did this. Okay, so a very similar question to what we just did here. It's not a lot of working, right? Finding sum of all the even integers between 39 and 93 inclusive. Obviously, you know, 39 and 93 is not even, so they wouldn't include them in the sum, right? But how would you go about doing a problem like this using your knowledge of APs, right? So again, you gotta think about the mathematics, think about what you have and think about what you need, and then just do the algebra. It's really just algebra at the end of the day, right? So we're just gonna steal these answers here. And just make changes. Right? Oh. Section 3. So the integers between these numbers here is really 40 and 92. They form an AP with first term 40 and common difference 2, right? So in this equation here, I put 40 and 2. And then we want to know what term is 92. So 92 is which term? 20th term, the 25th term, the 5th term, we don't know. Trying to figure that out. So I was linear equation here to solve. 92 is equal to 40. So 2n minus 2, right? 2 by n, 2 by minus 1. Right? This is equal to 3 plus 2n. So n therefore is 92 minus 3 over 2. It's good to put some brackets up here to show that they're all being divided by 2. 92 minus 38 is what? If I add 2 to these two numbers here, it's the same as 94. Not if I take away 8 from these two numbers here. I have different ways of doing it, right? But 92 minus 30 is 62. And 62 minus 8. Take away, that's 54. Check out your brackets. And that is 27, right? So 92 is the 27th term in this AP. Right? So then this SN here, you're plugging in 27. So that's what we're interested in. So let's see if I could simplify this now. So S27, this is 27 over 2. First term, the first even number is 40. As the 27th term we're looking at, but the common difference is 2. Okay, D is 2. A is 40. And we want the 20 is the sum of the first 27 terms. Right? The first term is 40, the second term is 42, and so on and so on. Just to simplify now, this is 80. Yeah. Actually, no, let me do multiply that out, right? Because I have a 2 here as well. 27 minus 1 is 26. So these 2's could cancel here. So this is, I just don't want to use my calculator if you all didn't really notice, right? 40 plus 26. That's 27 times 66. I know at this point, you could use a calculator. What is this value? 27 times 66 equals 1782. It's not a lot of even numbers between 40 and 92. It's not a lot of numbers. This should be the answer. I hope you all got this. Hope you all understand what I just did. All right, so that's pretty much it for this topic, arithmetic progressions, right? It's really just your algebra and your problem solving, how to kick in. What I want to do now is start reviewing trigonometry, right? So I'm going to start dealing with, let's see, in the course outline here, this is the arithmetic stuff here. We'll do vectors after we do trigonometry, right? See vectors and vector analysis. I already told you what chapters to study for vectors. Just one chapter. Chapter 33 is fine. So the vectors would come a little bit after with the dimensional analysis. We'll do that towards probably next after trigonometry, right? We are doing trigonometry first. If you scroll up here, you'll see trigonometry here, matrices. I'll tell you all the chapters to study for matrices, right? I'll go over that soon. around vectors, but we had to do some trigonometry. We already do the algebra. That was the first 10 lectures in the course, right? We want to review trigonometry. Trigonometry is very important for engineering, right? One of the most important topics. But it kind of builds on top of algebra, right? Again, your algebra skills have to be on point. If you're weak in algebra, like completing a square and factorizing quadratics and then we'll see real problems. Trigonometry doesn't have a lot of those things. For this course, the trigonometry we're going to use is fairly basic, fairly simple. So if you see up here, they say, well, you know, the ratios, quadrants in a different section, areas and volumes, sine, cosine rule, area, irregular areas, that kind of thing. Kind of more sticking towards that here. So that's what I kind of want to review now. What are the textbooks for trigonometry? Sorry, the chapters. You see 22, 26. Some of these chapters you don't really have to do, right? But the geometry, you should know how to find nice, simple areas and volumes and that kind of thing. So I'll do that just now. Let's start with the basics of trigonometry for those who kind of rusty, right? So basic trigonometry. I will start with something called a right angle triangle. Okay. Triangles have three sides and a right angle is a 90-degree angle. The symbolism for that is this little square here, this little square on a corner. When you see that little square, it means it's a 90-degree angle. And in such a triangle, a right angle triangle that has an angle like that, the side opposite the right angle triangle is called a hypotenuse. So people say hypotenuse is the longest side in the triangle, right? For a right angle triangle is the side opposite the right angle. So the right angle is here opposite to that is going up, so that's what the hypotenuse is. Now the tricky thing is with angles, when you're given an angle in a triangle, you only have three angles in a triangle. And if you have a right angle triangle, this angle kind of uninteresting, okay? Is the other angle that you may not know, like we don't know what this theta is. Theta is a Greek symbol, classic symbol to represent angles, right? As well as things like alpha, beta, gamma, all these Greek alphabet letters, right? If this is theta, the side opposite to theta is what we call opposite. So it depends on the angle. If I give you a right angle triangle and ask you what's the opposite side, you're supposed to say, I don't know. Because you never tell me which angle you're talking about. Opposite to what? Which angle are you interested in? Well, I'm interested in this one here, this one called theta. Well, then if that is theta, the side opposite to that angle is what we will call opposite. So it depends on the angle, right? The angle of concern to us. The side opposite to that is what we call opposite. Hope that makes sense to you guys. How you label triangles is a kind of tricky thing. Some people, you know, didn't know is how to label triangles a certain way. The convention really is you start labeling it in a clockwise direction using uppercase letters. The corners should be uppercase letters. So you can start at any point. I start on the left and I go in a clockwise direction, ABC. You tend to use consecutive or sequential letters from the English alphabet, right? You tend to use that. So like ABC, PQR, XYZ, that kind of thing. Not RMF, right? That's not consecutive letters. You don't really name triangles like that unless you don't have a choice, right? If you have a choice, you name it like that. Now, the side opposite an angle is given lowercase letters. So corner capital A, the side opposite it is common A, right? You see common C is opposite capital C, common B is opposite capital B, right? That's how you label a triangle. That's how you know what things are. From CSEC, we have the basic ratios for triangles. The ratios are defined for a really right angle triangle, okay? So it turns out that the ratio of the sides is actually constant for a triangle, for a certain angle. So it don't matter how big the triangle is, if the angle is a certain value, the ratio of the sides is in a constant ratio. And we use that to solve problems with triangles, right? So we define the sine of an angle as opposite over hypotenuse. That's where these things come from. These things are defined as ratios. Cosine of an angle is the adjacent over hypotenuse. Of course, you know, the opposite is the side opposite to the angle A. So if A is this point to the left bottom here, then opposite is the side common A, the side opposite it, right? And hypotenuse is opposite to the right angle. So sine A is A over C. Cosine A is B over C. The adjacent is just the other side. You have three sides. One is the hypotenuse, one is the opposite. Obviously, the other side is the adjacent. That's the side on the adjacent to the angle, right? And we call the tangent of an angle as the ratio opposite over adjacent. These things are defined. This is how they are defined for a right angle triangle. So let's try a simple question, right? This is on the level of CSEC here. Okay. Again, three consecutive letters, clockwise direction, PQR. Okay. Based on the diagram, we see at Q we have a right angle, a little square there to the bottom, right? So that's a right angle. So you know these ratios, sine, cosine, tangent, could be used, right? To solve the problem. So they told us angle P is 62 degrees. Okay, cool. They say find the size of the other angles, find the size of the sides and the angles. So how do you do a question like this? Simple geometry, we know that the sum of the angles in a triangle is actually 180 degrees. So I know what this angle is here by simple subtraction. Right, the 90 plus the 62, I need to add that up and subtract it from 180 degrees, and I'll get what that angle is R there. But what about the sides though? What about the sides? How to find the sides? That's a tricky part of the problem. Okay. So let me show you how the solution goes. I'll go through it. It's a kind of easy question, and it's on the level of CSEC. It's like a CSEC past paper question here. As I was talking about before, the sum of the angles is 180 degrees in a triangle. That's a basic geometry fact from Form 1 and Form 2 around there. So just simple arithmetic, you could find what that angle R is. You don't need that angle R to find anything else. They just say, you know, find all the angles on sides. So we found out. So we don't really need to find out. Let's talk about the ratios. We know this angle is 62. So what's sine of 62? What is the side opposite to 62 degrees? That's RQ. Or, you know, in alphabetical order, QR, right? So we tend to write things in alphabetical order. So sine 62 is opposite of hypotenuse. Opposite is QR. And hypotenuse is PR. PR is 11. Now I could find sine 62 on my calculator, right? But I wouldn't do it yet. Sine 62 is QR over 11. Change subject of the formula, right? Multiply both sides by 11. QR is 11 times sine 62 degrees. So what's that? I need to go on scientific here, right? So sine, how is it this way? 62 degrees, the sine of that multiply by 11 equal 9.71. 2 decimal places precision is fine for questions like this. So 9.71 centimeters. How do you find the other side? Well, the other side is the adjacent. Which ratio has adjacent and hypotenuse? Adjacent and hypotenuse is cosine. So we say, okay, cosine of 62 is adjacent of hypotenuse, which is PQ over QR. Sorry, PQ over PR, right? As the hypotenuse, as is seen here. PQ by 11, change subject to the formula, put your calculator and you find the side. That's it. This is basic trigonometry. This is what we call basic trigonometry. Given a triangle, a right angle triangle, find things. Find the sides, find the angles, that kind of thing, using just these three simple ratios. The ratios you use depends on the information you have. Here we had hypotenuse, right? The only ratios with hypotenuse is sine and cosine. If instead of this 11 was the bottom side, QR, if that was 11, and this is 62, then have opposites. So I'm dealing with sine and tangent. That means the only two ratios that have opposite. So, people ask the question, so how do you know which ratio to use? It depends on what you have. Yeah, look at what you have. I wouldn't use tangent if I have hypotenuse. We're using tangent for no hypotenuse inside it. That can help. You use what the information you have. You use that, right? I hope this makes sense. Besides sine, cosine, and tangent, we gotta get a little more sophisticated, right? So general trigonometry, you gotta kind of make peace with these things, right? Triangles have three sides and three angles, okay? They don't have a lot of complexity in that shape. But other shapes can be composed of triangles. So that's why I have no geometry of four shape figures. Not interesting because a four shape figure is really two triangles. You could split up everything, any shape you want, you could split it up into triangles, and therefore trigonometry gives you the mathematics to analyze any shape, any regular shape, right? Polygons are talking about, right? Things with straight lines. If they ask you to solve a triangle, is that this terminology you see a lot? If I give you a triangle and say solve this triangle, what it really means is find all the sides and the angles. So I could have given this triangle here and say solve triangle PQR. What I'm really telling you to do is find all the sides and all the angles, which is what we did, because that's what they told us to do. They were just directing it. The thing is, right, with triangles, you had to be given three pieces of information. Somebody can't give you two pieces of information and tell you solve a triangle. It wouldn't work. You need three pieces of information. And one thing must be the length of a side, right? You can't solve a triangle without knowing the length of a side. If you don't know the length of any of the sides and you know angles, that could be any triangle, okay? You just don't know enough. So what I'm saying is, you need two sides and an angle, any angle, right? Or you need two angles on a side. Any two angles on any side could work. Or you need three sides. Once you have the three sides, you're good to go. You could find everything else. To my knowledge, these are the only possibilities. So like if you go back to this question here, what did we have in this question here? We had two angles, a right angle and a 62, two angles, and we had a side. That's easy because knowing two angles, you could find the third one. But you need a side. If you don't have a side, then you don't really have a triangle. Okay? So general trigonometry, this is what you should always try and understand. You need three things, and one of the things must be a side. You can have triangles. I can give it triangles and a triangle and say solve this triangle. If you don't know any sides, there's infinite possibilities there, basically. So next comes our friend our favorite trigonometric guy, Pythagoras, right? Who lived way back in the day, and he has a very, very simple theorem. And you can believe how powerful this thing is. All of trigonometry, all of it, is just these two things here. These three ratios here, the definition, the basic ratio, there's the one thing, and the second thing is Pythagoras. That's all you need. With this alone, all of trigonometry, you could derive all them formulas and identities and all that jazz that you would see in this textbook here that we will talk about in a while. All those things come from these two simple ideas. In a right angle triangle, the square, the hypotenuse, which is C, at the longest side in the right angle triangle, the side opposite the right angle. The square of that side is equal to the sum of the squares of the other two sides. And I mean, when they say it in English, it like this last sentence there, when you say it in English, does confuse almost everybody. Just rattle this out fast and watch people, get a headache. The square of the hypotenuse is equal to the sum of the squares of other two sides. This is just confuse people. Now it's easy once you're generally familiar with maths, right? But for some reason, this is used to make people feel smart, apparently. People who want to look smart is just rattle off this last line and people will be like, oh my God, he's a genius, right? But no, not that hard. Gotta see this thing in action, right? So what we had, this shouldn't really be, I mean, it's trigonometry, so that's why I'll call it question 1. What question I have today? Hold on, I'm gonna backtrack. So I have example 1, example 2, example 3. Then I have, this should be question 1. I should probably call it example, example 4. Example 4. Example 5. So solve triangle ABC. If angle C is 90 degrees, AC is 4 and BC is 9. Right? That's the question here. Now these trigonometry is a very visual subject. You probably should draw a diagram for this. Okay. What's a good diagram for this? Look one here. It's an okay diagram here. ABC in a clockwise direction. Angle C is the 90-degree angle here. And well, AC is 4 and BC is 9. So I actually draw it to scale 1, 2, 3, 4 blocks on top and 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 blocks across. So this is a triangle here. How you're gonna solve this, right? Now one angle. You can't find the other angles miraculously. You have to find you got to use the sides. So I have 4 and 9, right? 4 is this side here and 9 is this side here. The angle at B, if I want to find the angle at B, then the opposite to B is AC, which is 4. So then I know opposite and adjacent. Which ratio is opposite and adjacent? Tangent, right? Tangent is opposite to adjacent. So I will have to use inverse tangent to find the angle at B. And then once I know the angle at B, is just arithmetic to find the angle at A. The hypotenuse, the longest side, AB, you use Pythagoras for that, right? So let's see how we could do this. So using Pythagoras' theorem, you had to label the diagram and say the formula in terms of the diagram, right? So AB squared is the square of the hypotenuse is equal to the sum of the squares of the other two sides, so AC, BC. And you're not doing it in alphabetical order. I'm not calling it BE, right? I'm calling it AB. So I know AC, they give us is 4 and BC is 9. So I substitute this here. Use a calculator, add up the numbers. That's not so bad. Again, this is still CSEC level. All right. AB is that 9.85, somewhere around there. The angle A, the angle at A, the opposite side to angle A is BC. And BC is 9. So opposite is 9 and the AC is the adjacent. So opposite and adjacent is tangent. So the opposite to angle A is BC and the adjacent to angle A is AC. Opposite and adjacent depends on the angle you're dealing with. Be careful. So tangent to A is equal to 9 over 4. So then A is the inverse tangent of 9 over 4. Right? Let's do that on your calculator. Inverse tangent. Second function. 9 divided by 4 equals, and then inverse tangent to that, 66.03. Well, 037, so that's 66.040. That's how I get that value there. This is read as the angle, A is the angle whose tangent is 9 over 4. Use a calculator for that. So now we know A, and we know C, we can find B. Just, A plus B plus C is 180 degrees. Just move things around and use arithmetic and you get what B is. That's how you solve a triangle like this. Given this triangle here, you really didn't need Pythagoras' theorem to find that. You could have used sine or cosine, because those have the hypotenuse, and you would just shift things around to find the hypotenuse. But this is a real easy way of using Pythagoras here to find that. But you don't need it for this problem. You didn't really need Pythagoras. Okay. So, what is this? Okay, so we have the ratios. Sine, say I have something like sine of x. Well, we use a. Sine a is equal to 0.35. Okay. So I have something like this. How you read this? So the sine of an angle A is equal to 0.35. That's how you would read this. The sine of the angle A is 0.35. Now, how you know what? How would you find that angle? How would you find that angle? You want to know what angle has a sine of 0.35. Okay. How do we find that angle? Well, we need to ask the question. What's the question? Which or what angle has a sine of 0.35? What angle has a sine of 0.35? Another way of writing that in mathematics, right? You'll say A how do you read this? A is the angle whose sine is 0.35, right? So you see, it's like the same thing here. What angle has a sine of 0.35? Well, I need to find the sine inverse. The inverse sine of 0.35 will tell me which angle has the sine of 0.35, right? So to find that on your calculator, okay, you type 0.35 and then you press the button inverse sine. See sine minus 1. So what you're trying to find is what angle in degrees has this sine. So that's the inverse problem, right? Finding the angle who has that sine. So you press sine inverse and you get 20.49 degrees. So this is 20.49 degrees. Okay, so if you know an angle, like say, 40 degrees. If I know the angle is 40 degrees and I want to find the cosine, you just press cosine and you see get a value less than 1, 766, right? But what if I know the value of the cosine is 0.766? So 0.766, I know that's the cosine and I want to know what angle has that cosine. Well, I'll use second function, inverse cosine. Inverse cosine tells me the angle that has that cosine. See here, 40 degrees, right? Almost, right? That's this notation here. One notation, sine of an angle gives you the ratio. Remember, ratio doesn't have any dimensions. It's the ratio of two lengths. That's what sine is. But if I know the ratio and I want to know the angle, you use the inverse sine function for that. So the sine function, given an angle, we know what the ratio is, right? The regular trigonometry give you the ratio once you know the angle, right? So if you know the angle and you want the ratio, you use a regular trig function, right? The inverse trigonometric functions give you the angle once you know the ratio. Okay? So they're the inverses of each other. If you know the ratio, if you want to find the angle, you use the inverse trig function. If you know the angle and you want to find the ratio, use the normal trig function, right? So I think that explains what this inverse tan is here. This 9/4, 9/4 is the ratio, because 9/4 is the ratio of the lengths, 9 divided by 4. But I want to know what angle has a tangent equal to 9/4. I don't know the angle. If I knew the angle, I could have just press tangent of the angle and I'll find the ratio. But I want to find the angle and I know the ratio. So if you know the angle and you want to find the ratio, is the regular one. If you know the ratio and you want to find the angle, is the inverse one. So I hope you all understand that little deviation I went into there. How you find the area of a triangle? Well, you say half base by height, right? But you have to take your time with our base. That's what we call the perpendicular height relative to the base. So it's easy for a right angle triangle. Okay, if you have a right angle triangle, that vertical dimension is the perpendicular height. So this is a classic formula that will never fail you. base by perpendicular height divided by 2. So that's B by A over 2 in this diagram here. The hypotenuse really don't play a part in finding an area. The other two sides will help you out because one is the base and one is the height because they're 90 degrees to each other. But you have other formulas for the area of a triangle, right? I wouldn't go into the proof of these things, but I have AB sine C, or I have AC sine B, or I have BC sine A. There's a pattern to it, you know. Wherever the angle is always sine, right? That's the first thing, is always a sine. A half multiplied by two things by a sine. If the angle is C, the sides is the other two, A and B. You see, if the angle is B, the other two sides is AC. If the angle is A, the other two sides is BC, right? That's the pattern, and remember in this thing. From this diagram here, right? C sine A, right? C multiplied by the sine of A is A, you know. That's the perpendicular height. And then you just multiply A by B divided by 2. So A, common A is really B sine C, right? Or in this case, C sine A, okay? So all these formulas here are equivalent, basically. You use any one based on what you have, right? So we could try an example here. Find the area of the triangle in question 1 above. So what's not question 1, example 5. So in example 5, we want to find the area. Well, the perpendicular height AC, which is 4, by the base, which is 9, 4 by 9 divided by 2. And that's what we have here. 4 by 9 divided by 2, 18 centimeters squared. The dimensions of the triangle was in centimeters, so that's why we say centimeters squared. Okay. And this formula is really useful to find an angle if somebody give you the area. Yeah. If somebody gave you area and they give you the two sides, it's kind of easy to find the angle between. But basically, it's the same formulas before with sine, cosine, and tangent, right? You could start with the area being AB over 2, and then you use your trigonometry and so on. So it is not like a critical thing, this area formula here. This don't give you no special powers that you didn't have already, okay? So that's area. We have the complicated formulas and we have the easy formula for it. The complicated formulas are very useful for when we have a general triangle, and that's where things start to get interesting. What's this general triangle I'm talking about? General triangle. For a general triangle, meaning you're not sure what the angles are. I have no right angle inside here. You don't know. I mean, you might look at A and A looking like a right angle, you know, but no, you can't be sure of that, right? That's what a general triangle is. You see the label there? We start on the top at A and we move in a clockwise direction. A, then B, then C, right? And then the side opposite the angle is labeled with the common letter. So this side is common CY. This top right side is common CY because it's opposite to angle C. Corner B, the side opposite is common B. The top is A, corner A, right? Opposite side to corner A is the base, which is common A. So if you label a triangle properly like this, you know, this is the right thing to do, and it helps you use the rules. Now you can't directly use sine, cosine, and tangent in a general triangle. You can't say sine C is opposite over hypotenuse and all them kind of matters, right? This is not a right angle triangle. Those things don't apply. So you have new ammunition, new weapons to deal with these things, right? The first being the sine rule. And again, the proof not so bad for this, right? But You don't need to know it really, you just need to know how to use it. These ratios are the same. And it's easy to remember. A over sine A, an angle divided by the sine, sorry, a side divided by the sine of the angle opposite it is a constant for all the sides. So if we take B and we divide it by the sine of the angle opposite it, is the same as side C divided by the sine of the angle opposite it, and so on. So if we know a side and the angle opposite that side, that's where the sine rule comes in. You can't really use it unless you have one ratio. You need one side and the side opposite, the angle opposite it. You need to know it, right? If you don't know it, you can't really use it. And again, this is for general triangles, right? We have no right angles in here. So the sine rule, it comes in handy when you ask it to solve a triangle and we know a side and the angle opposite that side. Now, when you don't know that, that's where another rule comes in. And this is scary rule. All of this is still CSEC level. We ain't doing anything advanced yet. Something called the cosine rule. Cosine rule have different forms and is possible to memorize what it is if you practice it long enough, right? A squared, right? You see A squared here is equal to, the formula has a pattern. A is on the left is the side, but cosine A is on the far right. So you see A, B, B, C, C, right? Look at the extreme left and right. You'll see the letters match. And it's just like Pythagoras, right? You see if this side is A, then you see the B and the C on the inside. If this is B, you see AC, AC. If the outside is C squared, you see AB, AB. It's the other two sides. So inside of here, on the right-hand side, you will see the other two sides, but the outside, you will see the third side. And the angle is the angle opposite to the third side. So these formulas have a pattern in them, easy to memorize. You use the cosine rule when you know two sides and an angle between them. If you don't have that, you can't use the cosine. Or if you know all three sides. So between the sine rule and the cosine rule, you have ammunition to tackle any triangle. But just remember general trigonometry. You hadn't be given three things. You have to know three things to solve a triangle. If you only know two things, these rules can't help you. So let's look at an example, right? What example are we on here? This is not question 2. We should say example 6. Example 6. We'll do example 7 on a solution 7 now. So given a triangle ABC, the angle C is 75 degrees, AB is 12.29, and BC is 9. I want you to sketch a diagram for this. You could use this diagram here, a diagram like this here. Draw a diagram just like this, label it ABC, and use these dimensions on it. And figure out which rule could help you. Is it sine rule or cosine rule? That could help you solve the triangle. When I say solve the triangle, I mean find all the sides and the angles of the triangle. Okay? Remember, this is not something you could use Pythagoras theorem. Pythagoras theorem is only used in right angle triangles. The cosine rule is the Pythagoras theorem, you know, when the angle is 90 degrees. So if you see cosine of 90 is 0, this minus 2bc term here goes away. And you have a squared is b squared plus c squared, or c squared is a plus a squared plus b squared. So cosine rule is more powerful than Pythagoras' theorem because it works for any triangle. Pythagoras theorem is only for right angle triangles. And you see that sine, cosine, tangent where you're saying opposite over hypotenuse, adjacent over hypotenuse, those things, that's only for right angle triangles. When you have a general triangle, the only two things you could really use is sine rule and cosine. And for area, this area formula up here, half AB sine C and its equivalent, right? So look at the sine rule, look at the cosine rule, draw the triangle, and see what you could use to solve the triangle, which means find all the other sides and angles in the triangle, okay? So draw a diagram. This is the first thing you do. There's a diagram here. I took the same diagram up here, ABC, put it here, and I just label it, right? C is 75. It don't have to be to scale, you know. AB is 12.29 and BC is 9 centimeters. We ought to look at what we have, so we'll know which rules that could help us. The sine rule, do we know a sine and an angle opposite to that side? Let's see. Remember, you can use Pythagoras, or the normal ratios like sine 75 is opposite over hypotenuse. We can't use them kind of thing here. We have a general triangle. I know an angle 75 degrees on the side opposite it, 12.29. So sine rule is what I'm going to use to solve this problem, right? So let me steal this here. I will use the sine rule for this. And what we will do here is write, we'll substitute into the sine rule. So A is 9, so 9 over sine A is B over sine B. We don't know any of the B's, the angle or the side, and C is 12.29 over sine 75. So let's focus on A for a while. 9 over sine A is 12.29 over sine 75. Okay. We could simplify that here. These are different formula to give some space. So I invert this last line here. So 9 over sine A, if I invert that, I get sine A over 9. And 12.29 over sine 75, I invert that, I get sine 75 over 12.29. I did that to make changing the subject of the formula easy. So I cross multiply by 9, sine A is 9 sine 75 over 12.29. And then again, if I know the ratio, because I could find this right hand side, that's the ratio. If I know the ratio and I want to find the angle, you use the inverse sign. So sine of some angle is this ratio. Therefore, the angle is that angle whose sine is this thing here. If you plug this in your calculator, you'll get 45.02 degrees. Right? Then we move on to finding the angle. So you could round it off. For this part, we can round it off to the nearest degree. So this is like 45 degrees. So B, that's A, right? B is 60 degrees, right? It's on the diagram there. And the other ratio we have is B over sine B. I just know what B is now, 60 degrees. So I could use the sine rule and the ratio that we were given, the C over sine C, right? 12.29 over sine 75. I could use that for B now. So B is 60, so I cross multiply, B is this value here. And I just substitute that, and I get 11 centimeters roughly. So there you go. That's how you would solve a question like this. How did I know I needed the sine rule? Because I had an angle on the side opposite it. I know that ratio. So sine rule is very good here. Again, you can't use Pythagoras theorem or the general sine cosine tangent. You have to use either sine rule or cosine. So hope this makes sense. So how about a different example, right? So this was example 7 on solution 7. We'll do example 8. And solution 8, right? So again, follow the same setup strategy. This is solve the triangle, means find all the sides and angles in the triangle. You're given ABC, so you could use the same diagram here and just label the sides differently. B is the angle you're given, which is 64 degrees. AB is 4 and BC is 7. After you draw a diagram, look at what you have and look at the strategies for sine rule and cosine rule. If you know a side and the angle opposite it, sine rule is very useful. If you know all three sides and no angles, cosine rule is useful. Or if you know two sides and the angle between them, cosine rule is very good to find the other sides and angles. So look at this example right here. Try and complete it. Don't forget, complete this question for homework, but also I gave you some arithmetic progression questions, 5 questions for homework to give you practice with the topic, right? Bear in mind that the algebra skills are going to have to be on a certain level to deal with these questions.